So as we go through the session itself, if anyone has any particular questions based on what I'm presenting, feel free to raise your hand so we can actually, or I can actually answer the question or provide feedback on the comment that you may have as we go through the deck. That's typically a lot easier. There's a slide up here with a disclaimer, and the reason for that is fairly straightforward. Today I'm going to be talking about the vision that we have from a storage and data perspective and also data recovery. So some of the things that I'm about to show you are things that we're actively developing as it is right now. So some of the technology may also not be released with VCF 9. I know Joe mentioned VCF 9 a couple of times, and I want to be very clear what that actually means because I think there's some mistakes out there. A lot of people actually expect all of the functionality that we talk about when it comes to VCF 9 to be released with VCF 9.0. Well, that's actually not going to be the case. Some of the functionality that I'll be talking about, for instance, may be released in 9.1 or 9.4 or 9.8, whatever it ends up being, I'm not sure. Everything is actively being worked on, but it's not set in stone just yet in terms of what the date will be. Now, from a storage and availability perspective, we're working on a lot of changes for a good reason. If you look at what a customer environment typically looks like today, and especially if you look at VCF customers, larger VCF customers, and you combine that with DR solutions, it kind of typically resembles something like this. There's a lot of different moving parts in every single estate out there. Now, it typically doesn't just stop with that. If you look at all of the different flavors that are involved, especially with storage systems, backup solutions, archive storage systems, typically multiple locations, if you combine all of these, then it adds a lot more complexity. We're talking about 5, 6 different types of block storage solutions. Add on top of that, there's file system solutions. Then those systems need to be backed up. They need to be protected against ransomware. It becomes extremely complex fairly fast. So as a result, it adds a lot of silos that needs to be managed. And typically, that burden is on you guys. You are responsible for it. So if something fails, you are the person that needs to go in there and actually bring those workloads back up and running. If there's a ransomware attack, well, you would probably be sweating for a week to try to get that data back to a certain stage in time where it actually wasn't impacted by the ransomware attack. And that is actually, as a company, something that we're aiming to solve. So we're trying to make it easier for all of our customers and partners to implement these solutions and to use these solutions. Now, of course, as Joe mentioned, and as you've probably heard at Explore and other years at the VMUG, we already have a solution for that in place, which is VCF. Now, there are a couple of challenges, of course, if you look at VCF itself and if you look at the stack that we provide, because it only provides a part of the solution. If you, for instance, look at the disaster recovery platform that we have available, yeah, it offers some of the components that will allow you to, for instance, create local snapshots. But for vSAN, for instance, we don't have a vSAN replication mechanism for snapshots as it is today. On top of that, if you look at VCF and vSAN itself, and if you've used vSAN, you've probably been using the HCI mechanism so far. We've also heard from customers that there were some challenges with that in terms of sizing and scaling, and especially with the customers that are deploying multiple petabytes worth of storage. Is anyone doing petabytes worth of storage in this room, by show of hands? Yeah, actually quite a number, which is surprising because in some cases when I ask this question, there's one hand that goes up, and here there's actually 7 or 8. So it says something about the type of customers that we have visiting this particular VMUG as well. Now, for those types of customers, what you'll typically also see, and this is something which I find interesting, is that a lot of the IT teams are still siloed, right? Now, VMware has always told people that you shouldn't be running your IT teams in a silo, and it should be one big virtual happy family, and you shouldn't have those networking teams separated from the storage teams, etc. But reality is that is still the case for a lot of our customers. And that's actually where vSAN, the disaggregated offering, comes into play. And I'll talk about that a bit more in depth as well. Now, before I actually start talking about vSAN itself, I want to give a brief overview in terms of what we see with our customers, because I also think it says something about how the platform is being used. Just as an example, one of our largest customers is actually using close to an exabyte worth of storage capacity in vSAN. Now, of course, that's not a single cluster, it's multiple clusters, but it says something about how they are deploying vSAN itself in their estate. And they're literally running every single workload on top of that platform. On top of that, if you look at the number of hosts being deployed with vSAN, it's also a significant number, 1 million or close to 1 million hosts actually. And the other one which I found interesting is the number of virtual machines. Now, what is probably most interesting is if you look at the number of hosts and you then look at the number of virtual machines. It says something about the consolidation ratio as well, which to me sounds fairly low. But those are the actual numbers that we gathered from the telemetry data that we have available as it is right now. Now, as I've mentioned, with vSAN and with VCF, we've been trying to create a solution which is not only efficient for folks in terms of capacity and performance efficiency, but of course is also easy to manage. Now, the last couple of years, we've actually introduced a new platform, which is vSAN ESA. By show of hands, are people already using vSAN ESA? Okay, that's just a few. Other folks using vSAN OSA? Yeah, that's the majority. Now, with vSAN ESA, we've created this platform for a very good reason. Right? If you look at the storage industry today, and you look at where we actually came from with vSAN OSA, when we designed vSAN OSA, that was in 2008, majority of you were still using spindles. Now, if you look at the world of IT today, the majority of you are using flash, and primarily TLC, so triple level cell flash. So when we looked at our platform, and we looked at all of the new types of hardware that were going to be coming out or that have been released over the last 12 to 24 months, we knew that from an architectural perspective, we needed to make a change to vSAN as well to allow you to use those types of devices in a more efficient way. So that is what we've done with vSAN ESA, the Express Storage Architecture. So this is basically a new architecture that allows us, going forward, to use all of the new types of flash devices, networking cards, etc., to use them in the most optimal fashion. So that's where vSAN ESA comes into play. Now, the big differentiator, by the way, from an operational perspective and probably from an architectural standpoint as well, if you as an architect or as an operator look at vSAN OSA and you compare it to vSAN ESA, there's one thing that will stand out, and that is the fact that vSAN ESA has a single tier of storage. With vSAN OSA, you have two layers, a caching layer and a capacity layer. With vSAN ESA, you'll have a single layer, which will cater for both. So that is the big difference between those two platforms. Now, of course, the big benefit of that is, if you're a vSAN OSA customer, you may have experienced that, if one of the caching disks fails, it has an immediate impact on all of the devices that sit underneath that caching device. So that impact could be significant, of course, depending on the amount of storage that sits underneath. With vSAN ESA, if a disk fails, it only impacts that disk. So that impact is much lower, right? In this example, 2 disk groups, the impact immediately would be 50% of the capacity. In that example, it's just a single disk, so it's probably single-digit percentages. So how do we go about doing that? Well, we actually implemented a couple of different processes additionally on top of what we've already had available within the platform. So we didn't rewrite vSAN completely. Basically what we did is we looked at all of the different layers within the stack, and we tried to figure out what we could optimize to ensure that we could use, for instance, these newer types of flash devices that started to become available, TLC, QLC, etc., in a more efficient way. The way we went about doing that is by introducing a new log-structured file system all the way up the top, which basically gathers the data, coalesces the data, and writes it down to the bottom layer as soon as we have what we call a full stripe write. So an efficient write to the lowest layer, the actual flash devices. The reason we are doing that, the reason we are coalescing the data is fairly straightforward. It is because majority of flash devices these days are optimized for a particular block size. And we've all seen these block sizes popping up, right? For a VMware workload, they're typically random. If you pick a single workload, you'll typically see, 8 kilobyte or maybe 32, whatever it ends up being, depending on the type of application. But if you have 5,000 virtual machines running, it's going to be very much random. So that's why we injected a file system in between that ensures that we can be smart about how we use that data. Now, if you look at that file system itself, and I think this is also an interesting aspect, it doesn't just simply coalesce all the data, but it actually tries to identify the size of the blocks that are coming in as well to figure out if it actually needs to coalesce the data or not. So if you have a small block, it will store the block in that, what we call a durable log or that log structured file system. But if we have a large block, which can already be efficiently written to the lowest layer, then we're going to write to it directly. So we have that capability as part of the platform as well, which makes vSAN an extremely smart storage solution. Now, there are a couple of other things that we've also done to the platform to ensure that it is a bit more efficient. Because we got some feedback from customers, and they said, well, if I look at the amount of CPU capacity, for instance, that vSAN consumes, it's quite significant. And there was a very good reason for it. If a single virtual machine with vSAN OSA does an I/O, and you have, for instance, compression and deduplication enabled, you have encryption enabled, and you are doing checksumming, and you have a RAID 6 object, that every single host individually needs to compress the data, needs to encrypt the data, and needs to checksum the data. Every single host with vSAN OSA does that individually. So that means we need to spend CPU cycles 6 times. Now, with vSAN ESA, we've actually made changes, and we moved all of those data services all the way to the top of the stack, which means that if this virtual machine does an I/O, this host, the first host that actually runs that virtual machine, is going to compress the data, it's going to encrypt the data, and it's going to checksum the data. And then, of course, that data is going to be spread across the other hosts in the cluster, meaning that we now save CPU cycles on those 5 hosts. So if you would do a comparison in terms of a benchmark, and you do a one-to-one comparison, then you will typically see that the amount of CPU cycles that ESA will use compared to OSA is about 30 to 40% lower, if, of course, you're running the exact same benchmark. Now, I've had some customers actually running benchmarks where we're just doing an all-out I/O performance test, and then, of course, what you will see is that ESA will consume typically more CPU cycles than OSA. The reason for it is fairly straightforward. ESA can also push 2 to 3 times more I/O than OSA can. So as a result, it will consume more CPU cycles if you're not doing the exact same test. So if you want to compare the 2 platforms, based on efficiency, make sure you run the same test. If you want to compare them based on the amount of I/Os that they can do in, of course, the amount of CPU cycles that they're then using is not as relevant. Now, I've already mentioned this briefly, but there are a couple of ways that you can actually go about using vSAN. Of course, there's the HCI mechanism. We've all seen and experienced that, considering most of you are actually vSAN customers. Now, we've introduced a capability a couple of versions ago that allowed you to start sharing vSAN data across clusters. There was a good reason for it, because what we started seeing with customers is that they had, especially those customers with multiple clusters, is that they started to see some stranded capacity within their estate. So some clusters had 0 capacity left, and other clusters would have 20 or 50 or 80 terabytes free capacity. So what we then enabled you to do within the platform is simply make a connection between those 2 clusters and actually share those data stores that normally in an HCI environment would only be locally to be available across clusters as well. Now, just so you know, for those who haven't used this yet, in the first version, it was called HCI Mesh. Then we renamed it to data store sharing. That's what it typically will say in the UI these days as well. And if you enable this, it's using a vSAN native protocol. So it's not doing iSCSI or NFS or anything like that. It's using a vSAN native protocol, and will actually use the vSAN client, which is already running on the host, to make that connection for you. Now, the next option that I've already mentioned earlier on that you will have available, or that you may already have available within your environment, is something that we call vSAN Max. And you can probably forget the name already, because I've just been informed that we are changing that name in the near future. As Joe said, we like to confuse people, so that's probably going to go on for another couple of years. But that name is going to go away. At least that's what I've been told, and it may not. Who knows? But that vSAN Max solution is basically our storage-only platform. So you can literally see this as a SAN or a NAS. It's basically a shared storage platform where we don't run any workloads. And you can expose that platform to other vSphere clusters, vSphere-only clusters, for instance, in your estate, or maybe vSAN clusters as well. So why would you want to do this? Well, I've already mentioned some of our customers that are running multiple petabytes worth of storage capacity. They have a siloed IT department. And what they've told us is they said, I don't mind running vSAN, but I would like to have the storage team actually managing vSAN. But I don't want to have the storage team actually managing our vSphere workloads. And I actually don't want them touching our vCenter server either. So with vSAN Max, you're capable of building basically a storage system which is managed by its own vCenter server, which can then be managed by the storage operators that can be exposed to other environments out there. So that's how we went about creating that solution. Now, there are, of course, a couple of other reasons why you may look at something like vSAN Max. And I was just talking to a gentleman earlier, and we were talking about licensing. Now, I'm not the person who likes to talk about licensing. A, because it changes every week, and B, there are so many details involved that I simply can't remember all of them. Now, if you look at vSAN Max, though, there is a reason why you may be interested in vSAN Max, and especially for those customers doing something with VCF, what we're starting to see in some of the estates is that the amount of storage capacity that they are entitled to simply exceeds the amount of storage capacity that they have running within the vSAN clusters at the moment. So what we're seeing with some of those customers is that they're actually building a vSAN Max environment because they already have that licensed in some shape or form from a capacity perspective, and then expose that capacity out to the rest of the world, instead of rebuilding clusters continuously with vSAN storage locally. So they found a way to get around that solution. Now, if you look at the platform, and I actually have a demo to show you as well, because that probably makes it a bit more clear what that looks like, it actually is pretty straightforward. As I've mentioned with vSAN, we have something called a vSAN client, and every single client cluster that likes to connect to vSAN Max, or what we call a server cluster, basically gets that client loaded. And that more or less happens automatically. So within the UI, there's simply an option that enables you, or allows you to enable vSAN as a client-only solution, which basically then runs that process on every single host that then allows us to connect that shared data store to that vSAN, or to that cluster itself. It's pretty straightforward. Let me show you what that looks like, because that probably makes it a bit more easier. If you look at this platform itself, we have a vSAN Max cluster and we have multiple compute clusters. This is 9.0, by the way. So in this particular case, I already have vSAN Max, or I have the cluster created, and I'm going to create a vSAN Max stretch cluster configuration. So I have a couple of options here, HCI, vSAN Compute Only, or vSAN Max. I'm going to select vSAN Max, and I'm going to select the vSAN Max stretch cluster, just to show you how easy it is to create a stretch cluster configuration. Now, of course, I need to do some validations in terms of the compatibility guide, if all of the components that I'm using are compatible or not. Then I can select some of the data services if I would like to have the duplication enabled, etc. And then I'll simply select all of the disks that are part of the cluster itself. Now, after I've done that, I simply need to create fault domains. So this is where we create two locations, site A and site B, and then I need to select a site C as a witness. This is literally all that it takes to create a stretch cluster configuration. And in this particular case, if you would run through this yourself, and you have to wait for the disks to be added to the vSAN data store itself, it takes about 10 minutes. That's all that it takes from a storage perspective. Now, of course, the most complex part here is having that conversation with the networking team to get the VLAN stretched or whatever is required to run data or run workloads across multiple environments. Now, as soon as you've done that, of course, we now have that vSAN data store, that vSAN Max cluster, and this is managed by the same vCenter server, but this could be running across vCenter servers instances as well. The next thing that we will need to do is we will need to go to one of the compute clusters and actually connect it. So that is what we're going to do next. I'm just simply showing you that we've created these fault domains and that stretch cluster configuration is up and running. So if we go to that compute cluster itself, there's a new thing that pops up from a vSphere perspective. First of all, you see two fault domains. That does not exist within vSphere today. So this vSphere cluster is also stretched across the same locations. Today, you're not capable of doing that. We don't allow you to connect the stretch cluster configuration, vSphere only, to vSAN Max. But with VCF 9, we'll be allowing you to do that. When you want to do that, the only thing you will need to do is you will need to make sure that you actually pair the data centers itself. In this particular case, the clusters are running within the same data center. So I need to make sure that data center A from a vSphere-only perspective connects to data center A from a vSAN Max perspective, that if we actually do I/O, the I/O remains locally. So we have that embedded into the platform going forward. So that is something that we'll support with VCF 9. And now, of course, the next thing that we'll need to do is we'll need to deploy a workload. We're deploying this workload on top of that vSphere compute-only cluster, and when we deploy that workload is going to be deployed from a storage perspective, of course, on that vSAN Max cluster. And when you look at that workload, it's also going to be stretched from a vSAN Max perspective across multiple locations. So all of that happens in a fully automated platform. Let me show you what it looks like, because if you go to the UI itself, you can see that we've deployed a VM, and you can look at the placement of the VM. So we show all of that information in the UI itself. So everything is embedded within vCenter Server. Now, as you can imagine, and I can already see some people, slightly confused, things like this will get confusing fairly fast, especially when you have a stretched cluster configuration. Because stretched cluster configurations, we don't really visualize them in the UI. On top of that, if you have multiple storage systems, with VCF today, and with vCenter today, when you look at those storage systems, you typically need to go to the cluster itself. So there is no federated overview. And that is also something that we're actively working on right now. So what we're planning for with VCF 9, I'm not sure which version this was going to be released, is an overview in terms of what it is that you have running within your environment. If you have vSAN OSA and ESA, if you have stretched cluster configurations, if it's running in storage-only mode, if it's running in compute-only mode, all of that information going forward will be available within the UI itself. Not only will that information be available in the UI, but of course you'll be able to actually start inspecting all of the different capabilities that are presented within the platform as well. Meaning that if, for instance, you have a stretched cluster configuration, you'll now be able to actually click to that stretched cluster configuration and see how that is actually geographically laid out within the country, or maybe even across countries, depending on, of course, the connection that you'll have. But all of that information is going to be available within the UI. Today, if you look at vCenter Server, you'll see a list of hosts, and you have no clue where they are running. Could be in data center A, could be in C, or in B. You have no idea. In this particular case, we're going to visualize what that actually looks like. And then, of course, you'll also be able to start drilling down to figure out if something is wrong with your environment, what is happening? So in this particular scenario, you'll see that we have a stretched cluster configuration, Madrid, Barcelona, and then the witness is in Valencia. If something would happen to my estate today, you would go to the health check, and you would see that something is wrong with the host, but you have no clue what the impact is on your stretched cluster configuration, for instance. We don't visualize that. Going forward, we will actually start visualizing within the UI immediately that something is wrong with one of your fault domains, which will hopefully then trigger you to start figuring out what is happening to your estate. Not only will we inform you that something is wrong with the fault domain, of course, the health check will also provide you some information around that. Plus, we will also see that virtual machines have been migrated or have been restarted in the other fault domain. And if there's an impact from a capacity perspective, we'll also show those changes immediately. So if you have a whole data center that disappears, then of course from a capacity perspective, you just lost 50%. All of that information is instantly going to be updated going forward. So that is something that from a VCF 9 perspective, we're now actively working towards, simply to make your life easier. And I can tell you some of these screens, like the visualization of a stretched cluster configuration, is something that I've been asking for 12 years. And this is the very first time that they're actually working towards building a solution. So hopefully we'll see that in the near future. And when we started out, I mentioned data protection, and I'm not sure if you've seen some of the data protection capabilities that we've offered as part of the vSAN platform today. The majority of you are OSA customers, so you may not have seen the new snapshotting technology that we've introduced with vSAN ESA. Now, I know we've introduced a couple of iterations of the snapshotting technology that we have available over the last couple of years, and every single time we said, the performance is going to be better. It's going to perform 3 times as well as it did in the past. And what we've seen, unfortunately, in most cases, is that if you create 2 or 3 snapshots, the performance would decrease extremely fast. We've solved that problem with vSAN ESA. Now, just like you, because I could see some people going, I don't believe you. Just like you, I didn't believe that either. When the engineering team told me, because they told Cormac and myself that 5 times already, we would always go to the lab and start testing it and then come back, well, you said 6% or 5%, but it ended up being 25%. Oh, what workload are you running? Well, we are running workloads that our customers also run. Okay, not a benchmark. No, it's not a synthetic benchmark. Oh, yeah, then it may look different. Well, then it's not going to be very useful, right? Because customers don't run synthetic benchmarks. But anyway, I wanted, of course, test that for myself as well to see what they were promising me was actually right. So what I did is, in my physical lab, I deployed HCI Bench with a typical benchmark run. And I wanted to make sure that the performance actually remained the same. So I deployed a virtual machine, just a single virtual machine. I just want to push the boundaries of what my systems were capable of doing and figure out what would happen if I would create multiple snapshots. Not one snapshot, but I'm going to create 5 or 6 snapshots. Of course, I'm not going to show the creation of 5 or 6 snapshots because that would be fairly boring. The important part here is the following: 45,000 IOPS, and look at the throughput and the latency. Those are the 2 numbers which are important. So what I'm going to do next is I'm going to create multiple snapshots on that virtual machine that is running that benchmark. It's going to be 5 or 6 snapshots. Now, typically, when you create a single snapshot, you will see 10–50% performance degradation. And then after that first snapshot, you will see additional degradation all the way up to 40–50%. In this particular case, it went from 45,000 to 44.8, and the throughput is down from 180 or 180 to 178. So that's literally it. Now, as I said, I did not create a single snapshot, but I actually created multiple snapshots. And as you know, as an administrator, deleting a snapshot is typically where it's most painful, because that's when the virtual machine freezes for a significant amount of time, when there's a lot of data that needs to be moved from one snapshot to the other snapshot. Now, that is something that we've completely solved as well. So I'm going to delete all of the snapshots, and when I go back, you will see that not only does the performance, there's a slight decrease, but goes back up immediately. The number of IOs, if you look at the graph itself, doesn't dip. It just goes down. It remains consistent. The reason for this is fairly straightforward. If you look at what we've implemented in the platform itself, is a snapshot based on metadata. In the past, what we would do with a snapshot is that we would have to create an additional file or an additional object, and then if you deleted the snapshot, we had to move data from one file to the other file. In this particular case, because it's all metadata based, and all of the data goes to the existing object or the existing file, the only change that we need to make happen on the metadata level. And that's why you don't see that performance dip anymore. Also, that stun that would normally happen, so the pause of that virtual machine, so we could copy over those last gigabytes worth of I/O, that doesn't need to happen anymore either. So that means that freeze, that could potentially be a minute or 2, is something you will not experience with vSAN ESA. Now, the nice thing about that is that going forward, not only will you be able to actually use vSAN ESA and create snapshots manually, but you can also do this in a fully automated fashion. So what we actually have available as part of the platform is called vSAN Data Protection. And vSAN Data Protection is a new option within the UI, which basically allows you to start scheduling snapshots. And these snapshots are now stored locally for now. You can provide a simple schedule, and actually have a demo for that as well, and that will simply in that snapshot schedule, you can simply provide how many snapshots you would like to provide locally, 1 per day, 1 per hour, 1 per month, and retain it for the next number of days. And then, of course, on top of that, we also have offerings available that allow you to offload those snapshots to cloud offerings at this point in time, but we're also planning on allowing you to do that on-prem, so between 2 on-prem data centers, instead of actually having the need to move to AWS or Azure or Google, whatever it ends up being. We realize that the majority of you already have multiple locations, so you may as well take advantage of that. Now, if you look at those snapshot schedules, and actually show those in the demo as well, they can be fairly complex, but there are 2 things which I think are important to realize. First of all, a virtual machine can only be part of 3 what we call protection groups, so 3 different snapshot schedules. And then a protection group can have up to 10 different schedules itself. So that could potentially add, a significant amount of complexity. You can make it as complex as you want. I tend to tell people to keep it as simple as possible for the first couple of iterations, simply that if something goes wrong, it's a lot easier to troubleshoot when you have a lower number of snapshots than when you have 200 snapshots per virtual machine, which is, by the way, the maximum amount that we support today, but we're actually planning on extending that to probably 1,000 as well. There's no reason from a technology perspective that we cannot go to 1,000. So what does that look like? Well, for vSAN data protection, if you want to deploy the vSAN data protection or use vSAN data protection, you first need to get the vSAN data protection Snap Manager appliance up and running. That's the first thing you need to do. So you need to download an appliance, get that appliance up and running, and then when you get that appliance up and running, you get a new section within the UI. Of course, you will only get that section in the UI when you're running vSAN ESA. This is only available for vSAN ESA at this point in time. Now, when you have vSAN ESA running, as you can see, this new screen pops up called Data Protection, and if you click on that screen, you will see that we get some information instantly available about the snapshots that may or may not be running. You can see if virtual machines are protected, so 75% of my virtual machines are protected, and you can see how much capacity is being consumed by snapshots, for instance. On top of that, of course, this is the section where you can create new protection groups. So this is where you can define these snapshot schedules. When you click on it, you can specify the name of the protection group, and you can specify if it needs to be immutable or not. Now, I played around with this, and I used immutability mode. When I say it's immutable, it truly is immutable. You cannot delete it or change it anymore. So that is something to realize. GSS can do that for you, but you actually need to have support phoning in to make those changes for you. The next thing, of course, you need to do is you need to add virtual machines to that protection group. I'm going to use a dynamic naming pattern, so I'm going to select star DE star, so all of the virtual machines that have the letters DE in there will be automatically part of this protection group. And the reason I'm doing that is fairly straightforward. If I add new virtual machines with those two letters in there, they will automatically be added to the protection group after I've provisioned the virtual machine. And then next thing, of course, that you'll need to do is you need to create a snapshot schedule, and that can be anything. In this particular case, I'm just using a traditional schedule, one snapshot every hour, save it for a day, one snapshot every day, save it for a week, one snapshot every week, save it for a month. Right? After I've done that, now, after an hour, the first snapshot of all the virtual machines that are part of that protection group is going to be created. Now, if you want to protect it immediately, you can simply click on that protection group and create a snapshot manually. You can always do that. So if for whatever reason you want to create a snapshot manually for any given protection group, you can simply click that box that says take snapshot and take that snapshot manually. And in the UI, we'll actually differentiate between snapshots that were automatically taken and taken manually on top of that. After the snapshots, of course, have been created, whether that's 1 or 100, you can now actually look at the different snapshots that have been created for this protection group, look at the virtual machines that were protected, and potentially restore those virtual machines. Now, there are two options here. When you look at the UI, it says restore VM and clone. Restore VM is an in-place restore, so it's going to power off the existing virtual machine and then do an in-place restore of that virtual machine. So it has an immediate impact on that workload that is running. The other option that you'll have available, which is probably the option that I suspect most customers will use, is the clone virtual machine. This is going to be a linked clone, but linked to a snapshot of that virtual machine that will then be instantiated. Now, before you power it on, I do want to make clear that it's going to be powered on with all the details of that virtual machine. So the name, IP address, etc. So if you're not using something like DHCP, you may have an IP conflict. So if that is the case, make sure you disable the networking card before you power it on. Now, of course, you not only have those options from a disk group perspective, also from a virtual machine perspective. You can go to a single virtual machine and simply look at the information for that virtual machine and look at all of the different snapshots that are available of that virtual machine itself. So you have those options available within the UI to actually restore on different levels, not just on that protection group level, but also on that virtual machine level itself. Now, not only is everything that you see here available through the UI itself, what we've also done, and this is probably the first time that this has happened, is we've also made all of this available through the APIs and the SDKs. So if you go to the API itself, you can create a protection group, you can restore a virtual machine, etc. Of course, William Lamb has already created a couple of Power CLI commandlets. These are community commandlets, so they're not available by default. You need to separately download them. But when you download those, and this is actually something that I've done in my lab, you can inspect the whole environment. You can get the information of the protection groups. If you get all of the information, you can delete the protection groups itself, etc. So all of those capabilities are part of the platform by default. Now, as I've mentioned, one of the things that we still do not have available today is the ability to replicate data between two on-premises data centers. So that is something that we're also actively planning for. So with VCF 9, the idea here is that if you have that local snapshot available, that it should also be possible to natively replicate that snapshot elsewhere. As you know, we have vSphere replication as part of the platform today, but the focus of vSphere replication today is virtual machines. Now, you can imagine that going forward, especially with the various types of workloads running on top of vSphere, cloud-native workloads, maybe doing something with vSAN file services or anything else, it should be possible to simply replicate objects from one location to the other location. And that is something that we're working towards with native vSAN to vSAN replication, which will have a 1-minute RPO. What that will look like is pretty straightforward. We've seen in the previous demo the different screens where you could specify what the snapshot schedule should look like. Now you can imagine that the additional screen would be configure replication, where you can simply specify the RPO, how many snapshots need to be created, how often, and what the retention period of those snapshots should be as well. Of course, when you do that, the idea is as well to extend that screen that we already have available to include the topology of where data is flowing between. So you know from a visual perspective immediately which data center is protecting which data center. And of course, that's not only going to be available within the vCenter UI itself, but the plan is also to make that available within the VCF admin console. So even if you have weird combinations going from left to right, or from top to bottom and left to right, all of that information will be exposed through the VCF admin console. Now, when we had this discussion with customers, something interesting popped up. There was one customer that mentioned this at the start of Explore. And I hadn't thought about that. Actually, no one within the company had thought about that. And it was a very interesting thing that they mentioned. So we created a slide about it because I think it may be interesting for those customers doing something with stress clusters as well. So they said they had a ransomware attack not too long ago. They were fortunate that they could recover because they found out fairly quickly compared to when most people find out. But they said in order to be able to restore from a ransomware attack in the future, what they actually wanted to do is create a scenario like this. And they already had a stretch cluster configuration in place. So they have a stretch cluster configuration in place. And they wanted to be able to replicate asynchronously all the snapshots to a third location. Now, this by itself, of course, is not something unique. But what they then wanted to do is they wanted to be able to actually split up that stretch cluster configuration, save one for potential police investigations or whatever is needed, and then completely complete the other, clean the other one, and recover all the data from that data protection location into this clean room itself. And that is something that I hadn't heard before, which I thought was a really unique solution. Of course, it also means that from a stretch cluster configuration, we need to come up with a solution that would allow you to do that, because we don't have that solution in place today. Well, we have the ability within the UI, but it's not as easy as it sounds. But from a conceptual perspective, I thought this was a very interesting concept, especially when it comes to trying to recover from ransomware attacks. Now, talking about stress cluster configurations, there are a couple of interesting features that we are working on at the moment. Are people actually running a stress cluster configuration? Yeah, a couple. So hopefully you'll find this feature useful. As you've noticed, or hopefully haven't noticed, but if you've done some of the testing with stress cluster configuration, you may have noticed that if 2 out of the 3 locations disappear at the same time, that third location that still exists, which may have valid data within that location, is no longer accessible from a vSAN standpoint. It goes completely inaccessible, which also means that all of the virtual machines running there are also inaccessible. So what we're planning for in the future is to provide you the ability to, within the UI, actually have an option to click Force Takeover and make that site fully accessible again and actually get those virtual machines that are up or that are available within that site itself up and running again. So it's simply going to list all the VMs that we can recover. If there are VMs that we cannot recover for whatever reason, they may have not been replicated, we'll list those as well. Not only in the UI, but we'll also add them to the log files, of course. And then after you've done that, all of the virtual machines will be automatically be recovered by vSphere HA. So that is something that we're planning for in the future, and this will be available in the near future. So we're talking about 9.0 or something around that time frame, maybe a patch solution or whatever it ends up being. The second solution that we're building, and this is actually based on feedback that we got from a customer in the UK, is the ability to actually place a site into maintenance. And the reason for providing or creating this solution is pretty straightforward, right? If today you want to do maintenance on the site, you actually need to go to every single individual host and place it into maintenance mode. Now, you can only place a single host into maintenance mode with vSAN itself. That also means that if you place all of these hosts individually into maintenance mode one by one, that there may be a discrepancy in terms of data that's being stored on all of these hosts. As a result, if anything happens to the remaining site, even though you've placed all of this in maintenance mode and all of the data is still available, they all could have different versions of the data, meaning it's inconsistent and would never ever recover. So what we're actually building right now is the ability to place a whole site into maintenance mode itself. And the way you would go about doing that is simply by clicking on the fault domain and say enter maintenance mode. At this point in time, we're going to migrate all of the virtual machines from one side to the other side, of course. And what we're going to do is we're going to pause all of the vSAN services at the exact same time and ensure that all of the replication that needs to occur locally to ensure consistency on top of that also happens. And of course, that means that if, for whatever reason, that second site would fail, now you could simply recover from the site that went into maintenance mode. Although it may have some older data, right, depending on how long the maintenance was, could have been an hour, maybe it was 5 hours or a whole weekend, at least you have the ability to recover all of the workloads if you want to. And then last but not least, the final thing I wanted to mention, because this is one of the features that we are still lacking from a vSAN ESA perspective, is that we're actually building vSAN global deduplication. So for those customers using vSAN OSA deduplication happens on the disk group level. With vSAN ESA, that's going to be global deduplication across the cluster. And it's going to be a post-process deduplication effort. And of course, there's a good reason for it, because if we would do this inline, globally, there would be a significant performance impact. Now, in this particular case, for those who are wondering, this process is also going to be a pretty smart process. So it's going to figure out if there's any significant I/O happening within your estate or not. If there's any significant I/O happening, of course, we're not going to actively deduplicate blocks, because workloads should be our primary focus. And with that, we've reached the end of the session. Hopefully it was useful. If there are any questions, I'm going to be around for the majority of the day, so feel free to approach me during one of the breaks. And if there's any feedback based on what you've experienced over the past couple of years with vSAN, I'm also happy to take that back to the engineering team. Thanks.